Hi everyone. I had to go to a meeting today, so I figured that I would videotape the lecture to try to help you out. So we're going to continue with naming and writing formulas. Today we're going to concentrate on the transition elements, which are the elements in the middle of the periodic table in the purple section. What's unique about these elements is they can have more than one charge. So they're often called multi-charged ions. You picked up a yellow card on the way into class today. You want to use that yellow card, the side that says transition metals and multi-charged ions. We're going to be referencing that throughout class today. So our goal is to determine the formula of an ionic compound formed between two given ions, and this is specific for multi-charged cations. So remember, the cation is the first element or the metal. Some of these can have more than one charge. And then our second target is I'm going to name an ionic compound given its formula. So multi-charged cations, you already know how to write the formulas for binary ionic compounds. The only difference in today's lesson is going to be we're going to talk about the elements in the middle of the periodic table. Some of these can have more than one charge. Something like calcium is always a +2. But if we're talking about iron, if you look on your yellow card over in the far right-hand corner, iron can have a +2 charge or it can have a +3 charge. So you have to figure out what is the charge on iron. As you look on your yellow card, there are two names for iron, iron 2 or ferrous and iron 3 or ferric. We'll try to talk about both of those naming systems. So whenever we're trying to write the formulas for multi-charged cations, we have to know the charge of that cation. So we can't just guess, is it +2 or +3? We have to know what the charge is. So in order to determine the charge of the compound, there are two systems that we can use. One is called the stock system, and one is called the traditional system. In both systems, the charge of the cation is given in the name. So for example, in the stock system, we use Roman numerals to indicate the charge. So iron 2 means that iron has a +2 charge. In the traditional system, we use endings that with ic or ous. The ic or ous ending is going to indicate what the charge is. Ferrous is iron +2. In the stock system, as I just showed in the example, the cation's charge is written as a Roman numeral in parentheses immediately after the metal's name. So if gold has a +1 charge, it's gold, parentheses, Roman numeral 1, end parentheses. The other example we could have is gold +3. So it would be gold, parentheses, Roman numeral 3, close the parentheses. In the traditional system, we use the suffixes or endings of ous or ic. Ous is telling us it's the smaller charge of the ion. Ic means it's the higher charge of the ion. An example again with gold, ris, ous, is gold +1, versus ric is gold +3. Another example would be lead. Plumbis is lead +2. Plumbic is lead +4. You will not have to memorize any of these names. You will be able to use this yellow card on any quizzes or tests. Here are some examples. Now sometimes students ask, where do we get these weird names for things like lead, for gold? It comes from the Greek or Latin root of the name. So you can see that iron, the reason it has the symbol Fe is because it comes from ferrum, which is a Latin root. Another example would be something like lead. It comes from plumbum, which is Latin. So let's look at some practice problems. We're going to write the formulas. Formulas are pretty simple, and we're going to follow the same rules that we did yesterday. You look up the charge of the cation, look up the charge of the anion, and then do crisscross. Remember that you're going to bring down the numbers, but the charges are going to go away. So chromic, if you look on your yellow card, chromic is Cu +3, and chloride is Cl minus 1. Now we're going to do crisscross. So take a second and see if you can write the formula. You should have gotten a formula of CrCl3. The charges go away and we cross over the numbers. Again, just like we did yesterday. Let's try our second example. Stannous fluoride. You have to look up the charges. Stannous is not on the periodic table. It's one of the transition elements. Stannous is representing one of the ions for tin. So if you look on your yellow card, stannous is Sn plus 2. Fluoride is in group 17. Fluoride is F minus 1. Now that I have the charges, I can do crisscross. So I get for a final formula SnF2. For our third example, we have mercury 2 nitride. In this example, they're using the stock system. In the stock system, the Roman numeral is telling you the charge of mercury. So we know that mercury is Hg plus 2. Nitride, if you look on the periodic table, is N minus 3. Again, you do the crisscross, the numbers come down and are written as subscripts, and the charges go away. So for this example, you would get Hg3N2. Ferrous sulfide. Ferrous is not on the periodic table. It's representing one of the charges of iron. Ferrous, if you look on your yellow card, is Fe plus 2. Sulfide is in group 16 and it's S minus 2. Do the crisscross, charges go away. Initially you get Fe2S2, but if you remember yesterday we discussed in an ionic compound we always simplify. So we have to simplify this formula. Both of these subscripts are divisible by 2, so that means that for our final answer we'll get FeS. For every one Fe plus 2, we need one sulfide ion. Copper 1 phosphide. Again, they're using the stock system. The 1 in Roman numerals is telling us the copper's charge is plus 1. Phosphide is in group 15. Phosphide is P minus 3. If we do crisscross, we get a final answer of Cu3P. Now, writing formulas I think you should have found relatively easy. It was the same process that we talked about in class on Monday. Naming is a little bit different. Naming multi-charged cations is different because you now have to indicate what is the charge of that element that can have more than one charge. So before the compound can be named, the charge on the cation has to be determined. Is the compound iron 2 chloride or is it iron 3 chloride? I'll go over some of the rules to help and then we'll do some examples. Rule 1. Separate the compound into its component ions, the cation and the anion. Remember, the cation is always written first, the anion is written second. The cation will always be the metal, the anion will always be the nonmetal. The second rule is cross over the subscripts to determine the charges. So we're going to do reverse crisscross. Remember, the cation is always written first in the compound and the anion is written second. So the first element is going to have a positive charge of some sort. The second element is going to have a negative charge. Rule number 3. Since the charge on the anion does not change, what this means is oxide is always going to have O minus 2. Phosphide is always going to be P minus 3. The charge does not change on the anion. So you want to check and make sure the charge on the anion is correct. If it is not correct, multiply the charge by a number to find the correct charge. The example is given. Let's say the charge on the anion should be minus 3. But when you do reverse crisscross, the charge is -1. That means you have to multiply both of them by 3, so that you would have the cation's charge and then you would have the anion's charge. Once the anion charge is correct, name the compound by first naming the cation, followed by the name of the anion. If the element can have more than one charge, you need to give both names, both the stock system, which is the Roman numerals, and the standard or traditional system, which is the IC or OUS ending. So we're going to try this first example. We want to use both the traditional and stock system to name SnO2. The first thing that we're going to do is we're going to break apart SnO2. We're going to do reverse crisscross. You can see the arrows. I'm going to bring the 2, and that's now going to become the charge of the cation. The cation is always the first element, so tin's charge is +2. When I do reverse crisscross for oxygen, I get oxygen to have a charge of -1. The second question you should ask yourself is the charge of the anion correct? Is oxygen supposed to have a charge of -1? No, it's not supposed to. It should have a charge of -2. I see that on the periodic table. It's in group 16. So that means I have to multiply both the cation and the anion by a factor of 2. So if I multiply the cation +2 by 2, that means the tin's charge is going to be +4. If I multiply the charge of oxygen, right now it's a -1, by 2, now it's going to have a -2 charge. So now that the name on the charge on the anion is correct, I can name the compound. Tin is going to have a charge of +4. So therefore, the stock system name is tin 4 oxide, and the traditional system name is stannic oxide. So you should give both names, tin 4 or stannic oxide. Let's try some examples and see if we can figure out the name. So we have HgO. If we look on our yellow card or even look on the periodic table, mercury is a transition element. Mercury can have more than one charge. If you're looking at your yellow card, you can see that mercury can be mercury 1 or it can be mercury 2. So when we name this compound, we have to make sure that we indicate the charge of mercury. First step is you're going to do reverse crisscross. If I do reverse crisscross, both of the subscripts right now are 1. So when I do reverse crisscross, mercury is going to have a charge of +1. Oxide is going to have a charge of -1. The next step is you ask yourself, is that the correct charge for oxygen? Should oxygen have a charge of -1? If you look at the periodic table, oxygen should have a charge of -2. Therefore, I need to multiply both the cation and the anion by a factor of 2. Now I can see that the charge of mercury is +2 because the oxide now has a -2 charge. So the correct names for HgO would be mercury 2 oxide or mercuric oxide. You should indicate both names. We want to get used to both the stock system, which are the Roman numerals, and the traditional system. The next practice problem we have is Ni2S3. Again, you can see that nickel can have more than one charge. If you look at your yellow card, it's in the middle column. Nickel can have a charge of +2 or it can have a charge of +3. Therefore, I have to indicate, is this +2 or +3? Some of you may have guessed what the answer for this is, but let's go through the process to make sure that we have it correct. We do reverse crisscross. That means the 3 is now going to become the charge of nickel, and 2 is now going to become the charge of sulfide. So we have nickel plus 3, sulfide minus 2. Next question is, you make sure that the charge on the anion is correct. Is sulfide supposed to have a negative 2 charge? Yes, sulfide is supposed to be negative 2. That means the charge on nickel must be plus 3. So the two names for Ni2S3 are nickel 3 sulfide or nickelic sulfide. Next example is PtS2. Now, platinum is one of the elements that's in the transition elements, but it's not on your yellow card. So therefore, it still can have more than one charge, so we'll go through the process to figure out what is the charge on platinum. If we do reverse crisscross, platinum is going to end up having a plus 2 charge, and sulfide is going to end up having a negative 1 charge. We check the charge on the sulfide. If we look on the periodic table, sulfide should have a negative 2 charge. That means we have to multiply both the cation and the anion by 2. By doing that, that now means that platinum has a plus 4 charge and sulfide has a minus 2 charge. Therefore, the name of this compound would be platinum 4 sulfide. That is the stock system name. Since platinum is not on your yellow card, we don't have a traditional system name for platinum. So you don't have to make something up like platinous or platinic sulfide. It will just be platinum 4 sulfide. The 4 indicating the charge for platinum because it is one of the transition elements. Our next example, we have AuN. If we look, again, gold is one of the transition elements, so we have to indicate the charge of gold. Remember, our first step is to do reverse crisscross. Both of these have a subscript of 1, so that would mean that gold would be plus 1 and nitride would be minus 1. Next step is to check the charge on the anion. Nitride is supposed to have a charge of minus 3. Therefore, we need to multiply both the cation and the anion by 3. Doing that, we now see the charge of gold is plus 3 and the charge of nitride is minus 3. Therefore, the name for AuN would be gold 3 nitride or auric nitride. Our next example is we have Pb3N4. Again, lead is one of the ones that's on our yellow card, so we have to figure out what is the charge of lead. If we do reverse crisscross, we will see that lead will get a charge of plus 4, nitride will have a charge of minus 3. Again, ask yourself the question, is that the correct charge for the anion? If it is the correct charge for the anion, then we don't have to multiply them by a factor of anything. So therefore, lead can be plus 2 or plus 4. In this case, lead is going to be 4. So the correct names would be lead 4 nitride or plumbic nitride. That's all the examples that we have today for the lesson. What I would like you to work on for the rest of class is the multi-charged ionic compounds worksheet. If you look at the worksheet, on the front side, you're just simply looking at the cations and anions formulas and then doing crisscross. A couple hints, don't forget that you have to reduce the subscripts. On the back of the worksheet, you are going to name the transition element compounds. Again, you want to do reverse crisscross so that you can figure out the charge of the cation. Remember the steps to follow. Reverse crisscross, check to make sure the charge on the anion is correct. If the charge is not correct, then multiply by whatever factor. Multiply both the cation and anion. For the names, you want to make sure that you give both names. So for instance, number 1 on your homework is HGS on the back. You would have two names. One name would be mercury 2-sulfide. The other name would be mercuric sulfide. For a couple of them, you will only have one name. For number 4, for number 8, for number 11, and for number 14, you will only have one name, just the stock system, only the Roman numerals. For all the other examples on the back of the worksheet, you should have more than one name. Try the worksheet and then we'll go over it on Wednesday and we'll see how you did.